Alright guys, we're going to look at functions a little bit more. So last week we looked at relations, and a relation was any set that you would take members from the domain and into the range. So a function, however, is going to be a relation in which each element of the domain is paired up with exactly one member of the range. So the domain X is paired up with the range Y. So what this means is only one X can go to exactly one Y. And you're going to see it more as we go through some of these problems. So one X goes to one Y. So if we were looking at this example 1, determine whether the relation 6, -3, 4, 1, 7, -2, -3, 1 is a function, and explain. What we're going to look at is the x values. We're going to make sure that none of them repeat. So 6, 4, 7, and -3. So 6, 4, 7, and -3. So what we notice is not one of them repeats. It is okay to repeat our y's. If you notice, we have one in our range here and one in our range here. That's okay. It is not okay for our x to go to two different y's. So this is a function because each element of the domain is paired with exactly one element in the range. I'm going to show you guys the mapping here, and that might actually make it look easier too. So, and I'm not going to worry about putting them in order. I'm just going to go 6, 4, 7, and -3. But then our y's were -3, -2, and 1. -3, -2, and 1. And if you notice, we only did 1. We only wrote 1 once here because we don't need to write it twice. So 6 went to -3. So 6 went to -3. 4 went to 1. 4 goes to 1. 7 goes to -2. And -3 goes to 1. So what you're seeing is each of our x values only have one line going to it. Whereas our y value, we have 2 going to 1. That is okay. We are able to have two different y values, as two of the same y values, as long as they're for two different x values. Can't have x go to two members. So next thing I want to teach you guys is called the vertical line test. Vertical line test. So anytime we have a graph, we can quickly determine whether or not it is a function. And the way we do that is we drop vertical lines. So if you draw a vertical line through each value of x, if that vertical line only passes through one point, then it is a function. So if you see this line, it keeps going. I draw a vertical line here, it only went through one point. If I draw another vertical line, so all throughout here, I can draw vertical lines and it's only going through one point. So I'm drawing multiple vertical lines here, and it's only going through one point of my graph. I didn't like that. There we go. So they're going through one point. So this is a function. That is a function. If I were to, I'm going to go ahead and show you this real quick. So if I were to express this as example 1 as a graph. So I'm going to just throw a graph together real quick. And I'm going to just plug the points. It's not going to be perfect, but it'll be good enough for what we're doing. 6, -3. 6, -3 would be here. 4, 1. 4, 1 would be here. 7, -2. 7, -2 would be here. And -3, 1 would be here. So we have a graph here. If I were to draw a vertical line through each of these points, if you notice, my vertical lines, my dotted red lines, they only go through one point. That's a quick way to determine if it's a function or not. So we're going to go over and do some examples, and then we'll do some problems together. So if I were to remember what I said, if I see a graph, I'm going to do the vertical line test to determine if it's a function. So I'm going to drop vertical lines through these points. So let's see. There's a point here. So if I drop a vertical line through this point, look at that. Only one point it goes through. One point it goes through. 1 point. 1 point. 1 point. So if you notice, my vertical line never went through more than 2 points, right? Never went more than 1 point. So yes, that is a function. Yes, function. Let's do here. If you're looking here, I have multiple points, right, on this line. But if I draw my lines, that's only going through 1 point. That's only going through 1 point. That's going to go through 1 and 1. So this is another yes. That's a function. And I'm not going to type that for you guys. I'm going to let you guys do that in your work. So if you're paying attention, you have your work done. Let's talk about this mapping. So remember, each x has to go to exactly 1 y. So if you look, 0 goes to 1, y is 7, 1 goes to 6, 2 goes to 5. But this -1 goes to both 4 and 5. Because that x goes to 2 different y values, the answer is no. It is not a function. No, it is not a function. So we have yes, yes, no. I'm going to leave these ones for you guys to do on your own. But you guys know, drop your vertical lines. If it goes through more than 1 point, it is not a function. If it doesn't, if it only goes through 1 point, it is. If it goes through more than 1 point, it is not a function. If it goes through only 1 point, it is a function. So, for these ones, you can do this 2 ways. I can do it by looking at it, 4, 2, 6. None of them are the same. That is a function. -3, -3, -2. Well, I have 2 -3s, right? This is a -3 and this is a -3. But they go to 2 different y values. So no, that is not a function. -1 and 1, they're not the same, so it is a function. Pretty quick. Boom. So we have yes, no, yes. So here, what we have is you can graph these. And so I'm going to help you guys out, and I'll sketch the graph for you. So when x is 0, y is 0. Alright, let's see. So it's going to look like this. So that's my graph there. I'm not gonna comment on it. You guys can do that on your own. I'm just gonna draw the graphs for you guys. So x squared plus y squared, that's going to be a circle. With center at 0, 0. So I'm going to do that in red. And you guys are going to determine whether or not that is a function on your own. And then I'll do this one in orange. X equals -4, so x equals -4 is right here. So that's the graph there. And so you guys are going to tell me if each of these are a function or not. Have a good one, guys. I'm going to erase some of the answers that I did, but some will stay up, and you guys will answer it on your own. Thanks, guys. Have a great day. Bye-bye.